In this video, I'm going to discuss Euclid's Book 1, Proposition 12. And the nice thing about Euclid is he gives you a lot of times a lot of givens before he asks you to prove anything. So let's start with the givens. And hang on just a second, my camera is trying to fall down. Alrighty then, I know that kind of looks butt ugly there. Alright, let's get into the proof. First of all, he says there's an infinite line. It has 2 points on it, A and B. Now imagine a train. Well, not a train, but a train track. And you look down one way and you see forever and forever, and you look down the other way and you see forever and forever, and you don't really see the end of the railroad track. That's kind of an infinite line right there. Alright, now I know railroad tracks actually do have an end, but we're just using our imagination and saying, hey, gee, this railroad track doesn't end at all. It just goes on and on and on forever. Alright, the next thing he says is, I'm going to give you a point C. So what he says is he wants you to put a point C above the line AB. Okay, this is an infinite line, has 2 points, A and B. Now you're going to put a point C way up here. And then he's going to say, I want you to make yet another point below AB called D. So you do. So now you have line AB, point C, point D right there. Alright. And then he says, now what I want you to do is I want you, hang on just a second here, just got to turn the page. He says from an infinite straight line, and actually from a point not on that line, you're to draw a perpendicular from that point to this line. Well, how do we do this? Well, he says, I want you to use centermost part C and outermost part D. Here's outermost part D here. And we're going to use this, and we're going to make a circle. And it's going to be called EFG. Okay, you see this great big circle EFG? Now, I know it's not perfect. Don't worry about it. That's not the point. The point is, when you draw it, it will be. Alright? See, now you have EFG. Now, he says that I want you to come up with a point H that bisects line AB. Okay, that's all it does. Point H bisects line AB. Now, how do we come up with this? Alright, what we're going to do is we're going to utilize points E and G. We're going to make a equilateral triangle, and that triangle is going to be EIG. Okay? And when we do, we're going to use that equilateral triangle to bisect AB at point H. Alright? Now you remember doing this in Proposition 110. Alright. Now, AB has been bisected by H, but we haven't proven everything yet. Alright? Now, the next step is that since we had centermost part C and outermost part D, we made this great big circle. Well, one point on that great big circle is G, the other point is E. So we're going to draw two lines, CE and CG. And believe it or not, those two lines are going to be equal because all radii of a circle are equal. Alright? Now, you just happen to notice that when we had this H right here, we were able to draw a line from H to C. Alright? So CH equals CH, and that's because equals are always equal to themselves. Alright. Now, we bisected AB, and because of this, we have also, since it extended out, HE and HG are equal. Alright, so now we have CH, CE, CG, CE and CG are equal because already I have a circle are equal. HE and HG are equal because this AB line has been bisected. And so therefore you have triangle HCE equaling size to HCG. That means that angle CHE is equal in size to CHG, and therefore, since these angles are equal and they're adjacent, then this is a right angle here, and this is a right angle here. CHE is a right angle, and so is CHG. And that's what you were trying to prove in the first place. Alright, I will talk about more in a future video. If you have any questions or comments, leave them right down here. I will see you soon. Stay tuned.